My name is Evan Jackson. Foremost, I'm a through hiker, which means that I hike long distances from point A to point B. I don't do a loop. The biggest ones I've done are the Appalachian Trail and the Continental Divide Trail, which are 2,000 to 3,000 mile trails where you're on the trail for 6-7 months at a time and hiking 15 to 20 miles every day. Ultralight gear. Because we're hiking so far, so fast, we need everything to be light. And water. Obviously, I need a water filter and a way to carry water. Personally, I'm a fan of water bladders. Yeah, what are some problems with my water system? Sometimes it's hard to clean. If I have to take it out of my bag, that's annoying. It's hard to keep track of how much water is in the bladder, and sometimes I lose track of how much water I've drank throughout the day. I'd say those are some weaknesses of the water bladder system. The HydroHomie. The HydroHomie is an inline analog device that allows you to track how much water you drink while you hike. It has an analog face, the glass front rotates, and allows you to set either a goal or set a 0 point from the very beginning of your day to track how much water you drink. Up next, we'll see an animation. First, you'll see that the dial on the front moves, allowing you to set the 0. The gear train inside is calibrated to provide accurate readings of how much you have drank. The next feature that we have in this device is the fully analog mechanism. As you can see, there's an impeller, which drives a bevel gear, which drives a worm and spur gear. The advantages here are that the worm and spur gear are able to gear down the ratio a lot and activate without a lot of torque, which enables the impeller to spin freely. We'll now see that in another animation. Again, you can see that the dial moves, and then we'll start rotating around and uncovering the mechanism. You can see that the impeller drives the gear, and the needle moves, as it should. A large advantage of this device is that it's completely driven by the user. There's no need for an onboard battery, and you won't have to keep track of the battery while you're hiking. This is especially useful because there's a lot of batteries to keep track of while you're hiking, and as long as you can suck water through it, it will work. This product features a barb hose fitting to allow for universal fit. Most water bladders have 1/2-inch rubber hoses, which fit onto these barbed hose fittings, as we can see on the Camelback Crux reservoir or the aquatic weight bite valve. This allows us to create a product that fits onto every off-the-shelf product instead of having to create our own HydroHomie water bladder. One of the largest considerations for this product is its size and weight. Here we have it compared to an iPhone, where it's significantly smaller and lighter. This is a desirable product for the average backpacker. Now I want to talk a little bit about the engineering that went into this. The essential characteristics of this problem were that there needed to be a product that could sense and measure flow over time and show it to the user. It also needed to have some sort of internal power, be transportable, and lightweight. Using a decomposition table like we talked about in class, I came up with many different ways to solve each of these different problems. And combining them came up with some interesting concepts. The initial frontrunners that I found were similar, both fit in line the water stream, but one was also completely analog but featured a dial much more like you find on a lock, then the other one was electric. It would have Bluetooth and integrate with the smartphone and the smartwatch. So both were driven by impellers like my final product. By going through the brainstorming process, I decided to go with an analog dial that would be powered by its own flow. It would be held in line with the water pipe. And finally, I would optimize for lightweight by both its material, size, and its simplicity. Here are my original hand drawings, and we can see something similar to my final design. The impeller and the gear train turned out similarly. Now, the real question is, does the math work out? And the answer is yes, in theory it does. I was able to come up with an equation that related the total mass throughput to the rotation of a propeller. Now, what would this cost? I set a retail goal of $50 to $60 based on the idea that backpackers spend a lot of money on high quality equipment, such as spending $500 to $600 on just an ultralight tent. But my estimates are a little bit high because I have no idea how much it would be to make this gearbox. They're really small parts and would be complex to make, and so my estimate is above that goal. Now, this design isn't perfect. It's not finished. First off, the impeller spinning is the primary problem in my head. The bearings I used are food grade bearings, but they are slidey rather than roller bearings, and I don't know if they would work and help the impeller to spin or restrict it. I would need to do some research on that. I also don't know how fast the impeller is going to spin when a human is sucking water through it. That's going to require some empirical testing, definitely. And finally, manufacturing those really small gears it's going to be hard. It's done in a watch, but that seems cost prohibitive and difficult to develop. Finally, I think the HydroHomie has a lot of potential. This was fun to design. I want to thank Dr. Matson for a great class and wish him happy holidays and Merry Christmas.